Be here this morning. So I thought I'd start by talking a little bit about what brings me here today to talk about science and church. Why science and why in church? So I've got this picture collage behind me. I picked out a few things from the ever so useful internet with some things that maybe help symbolize why I became a scientist and why I might be here today. So up there you can see, I think in the upper right corner, what is that? That's a tent, right? In a lovely, mountain scene or something. So I did a lot of camping when I was a kid. My family and I traveled the country and did tent camping and tent camper camping. And I grew up in a place that was, filled with natural beauty as well. I was in a small town in Appalachia. And so I spent a lot of time outdoors. I got to see a lot of beautiful parts of our creation. And it just gave me a real appreciation for all the amazing stuff that's out there. I'm sure many of you all have had the same experiences, right? So this is not necessarily unique to me, but it's, I think it helps sort of foster my interest in, what is this world all about? Perhaps a bit more apropos is this thing you see on the right here. What does that look like to you all? It's a pocket watch. That's good. And what's that pocket watch doing? Yeah, that's right. So I think this picture came from like some sort of hypnotism site or something, but that's not what that's about. I'm not a hypnotist. What is that? When you hypnotize somebody with a watch, if that's what you do, I don't know. What are you doing with the watch? It's oscillating like a pendulum. I think I heard a pendulum there, yeah. So one of the first kind of real science experiments I did when I was a kid, and I think I was in 8th grade, is I recreated a famous experiment that Galileo did. So you guys have all heard of Galileo probably. If you have not, just in case, Galileo was a famous scientist who lived in the late 15, early 1600s, and he's known for a lot of things, but you may not know that he's known for developing an equation for how the pendulum works. And it turns out that the period of a pendulum swing is related to its length. So the longer the pendulum that you have, the longer it takes to swing. And so I did this experiment where I changed the length of the pendulum, and I measured its period, right? So it's a very easy experiment. I was in my dad's workshop in the basement of my house, and I used some sort of crude weight that was just lying around, and I would change the length of the string, and I would, measure it as precisely as I could with my stopwatch. And then, like all good scientists, I took a piece of graph paper, and I plotted the period of the pendulum as a function. So on one axis was the period, and on the other axis was the length of the string. And I looked at all these dots, and I kind of stared at it for a while. And my dad was there, and he looked at it, and he said, "Oh, well, that's a parabola." And I said, "Wow, what's a parabola? That's so cool." This idea that this particular pattern has a name, right? And that it related to some mathematical equation that Galileo had developed. So I still remember that as this really exciting moment of delight, at the way that we could think about the natural world and explore it and quantify it using math. And that was really cool to me. Sort of another thing that relates a little bit more to the thing that I do now, which is astronomy and physics, is this last picture here, which is, it's a very lovely picture of a father and son spending time outside looking through a telescope at the moon. And who knows, this may have been photoshopped, I don't know, but it's a pretty picture. But the point is, my dad had an old telescope that he had built when he was a kid. It's just a 3-inch telescope. Again, not too different from what Galileo used. He used just a very small telescope to make some of the first telescopic observations of the universe. And this old telescope that my dad had, it got to my house at some point, and I would just pull it out at random times and look at the moon, look at the moons of Jupiter, just really things that are pretty easy to see, but that just wowed me. And I grew up in a place where the skies were pretty dark, and so I could also just go out and look up at, find other stuff in the sky too with my naked eye. So this, it really became clear that this is, the stuff that excited me was astronomy. And it never fails that, going outside on a dark night or looking through a telescope at the craters on the moon fails to give me, it never fails that it gives me some thrill. And I've, been doing this for a long time. I don't know if any of you all have been out recently in the early morning. Has anyone been up, say, at 6 a.m. before the sun rises? I see plenty of nods, yeah. What have you seen early in the morning when it's been clear? Has anybody seen? What's that? Venus, that's right. So Venus has been bright, and then there's also been another planet out. Has anybody noticed that? There's two really bright things in the east in the morning. There's Venus, and then Jupiter has also been out. So take a look. If you're up early in the morning, look towards the east and see what you can see. And you can ask me later, there's an easy way to tell whether it's a star or a planet. Does anybody know that trick? So look to see if it twinkles, and if it doesn't twinkle, then it's a planet. That's the trick. All right, so what is the common theme here? And I would say that it's wonder at the beauty and mystery of the universe. So I'll say that again, wonder at the beauty and mystery of the universe. So I think that's something we can all share, right? But in particular for me, it's something that makes me want to do science. All right. What about faith, right? So I'm here talking about science at church. I do have a faith story too, right? And so again, this is sort of a picture collage of some of the things that make me a Christian as well as a scientist. And I think, again, starting at the top right there, this idea that God is a creator and that, spending time appreciating the natural world, for me, that helps me see that, that it is beautiful and that, this thing had to come from somewhere. So it gives me faith in God as the creator of the universe. And it inspires my faith to see the beauty of the universe. I think sort of equally importantly, so this is an icon that I picked out. Again, that is a famous one. I'm sure you all have seen things like it before. Do you guys know what this depicts? Does anybody know what this depicts? The Trinity, that's right. So it's a famous icon that depicts the Trinity. And often in theology, the Trinity represents community, right? And so I would say that the community of faith is something that's super important for me, and I'm imagine for many of you as well, right? Starting out with family, but also the Christian community, the church. And I think those things are really important to nourish and to help me grow in my faith. And then the final thing is, this is just a picture of a nun praying, but I think, I experience God in prayer and silence as well, so the inward journey, right? So not just the outward journey of, seeing the universe and seeing God as the creator, but also the inward journey of contemplation. And so again, the common theme here is, wonder at the beauty and mystery of God, right? So not just the universe, but also of God. All right. So are you ready to talk a little science, maybe? Yeah. All right. So kind of keeping on that theme of wonder at the beauty and mystery of the universe of God, how do we experience a sense of wonder in science and faith? So let me talk a little bit about science first, and I'm going to show you one of my favorite images. So this is my favorite image of the cosmos, and it's one I show to most of my students at one time or another. And in essence, it captures the entire universe in one shot. Okay, not actually the whole universe, but enough of a slice that we can say this is what the universe looks like. Okay. Does anyone know what this image is? It is of the sky, yes. It's a lot of galaxies, that's right. It's a whole lot of galaxies. There's a few stars in there, but almost everything is a galaxy. Yeah. So this image is called the Hubble Ultra Deep Field. So raise your hand if you have heard of the Hubble Space Telescope. Okay, most of you, not everyone, and that's cool. So the Hubble Space Telescope is a telescope that's been in orbit around the Earth for about 25 years now, and it's made some really amazing discoveries. But one of the great things is that because it's above the Earth's atmosphere, it enables us to see really clear pictures of things out in space. So it doesn't have to deal with the blurring effects of the Earth's atmosphere. So back in 1995, so that was 23 years ago now, Hubble stared at a tiny region of the sky for 10 days straight. Okay? And this view has been updated several times, most recently in 2014. So this is the, version 6 or whatever version it is. And it required 53 days of staring in all. So you can think of telescopes as light buckets. If you've ever seen a telescope, the mirror or the lens is circular, right? So, and it has a tube on the side, so it's kind of helpful to think of a telescope as a light bucket. And so the longer let's say you want to collect rain, right? If you put a bucket out in the rain, the longer you leave it there, the more water you're going to get in your bucket, right? So it's the same with a telescope. The longer you point a telescope at something, the more light you're going to get in your bucket, and the better you're going to be able to see things that are really far away. All right, so we've already heard what you can see in this image. It's a whole bunch of galaxies, right? What are the most distant galaxies in this image, do you think? What's that? The least bright ones. Yeah, that's good, right? And the size. So what about the size tells you about how far away they are? Teeny weeny, right? Yeah, exactly. So the teeny weeny ones, or the really tiny ones, right, are the ones that are what? Furthest away. That's right. So if you sort of imagine that all galaxies are roughly the same size, which is not a terrible first approximation, as scientists like to say, the close ones that you can see here are the big ones. And then the ones that are furthest away are really tiny because they're so far away. And in fact, the ones that are furthest away you can't even see from where you are. It turns out that there are tens of thousands of galaxies in this image. And some are just little tiny smudges that astronomers have to use really special software and look really hard to find these really faint things. Okay? They're just little smudges. It turns out that another thing that happens as you look at very distant galaxies is they turn red. So the universe's expansion kind of stretches out the light from the galaxies and makes them more red. So the far away things are also really red as opposed to blue. So in astronomy, seeing further away means that we're looking back in time as well. Okay? So it turns out the universe has a speed limit. So you can't go faster than this speed limit. Does anybody know what that speed limit is from thinking back? Sorry, what's that? I saw somebody raise their hand there. Oh, okay. What did you say? Speed of light. Yes, that's right. Speed of light. So nothing can go faster than the speed of light. And the speed of light is really fast, okay, but it's still a speed limit. So nothing can go faster than that. Light is, of course, what's traveling to your eyes from all of these galaxies. So it takes time, because there is a speed limit, it takes time for that light to get to you. All right? So the things that are really close, it doesn't take that long, right? I mean, relatively speaking. So when you look at those nearby things, well, let's take an easier example. It takes the light from the sun about 8 minutes to reach Earth. So when you get the light that reaches your eyes from the sun, are you seeing the sun as it is now, right now, or are you seeing the sun as it was 8 minutes ago? So it turns out you're seeing it as it was 8 minutes ago, right? You're seeing it now, but you're not seeing the sun as it is right this second. You're seeing it as it was 8 minutes ago because it took the light 8 minutes to get to your eyes, right? Similarly, the nearest star is 1 light year away, and a light year is the distance it takes light to travel 1 year. So we're seeing the nearest star right now, if you were to look up and look at Alpha Centauri, which is the nearest star. star system. You're seeing it as it was, how? A year ago, that's right, okay? So, extrapolating, the things that are furthest away, we're seeing them as they were a long, long time ago. And the further away they are, the longer in time we're looking back, right? So in essence, we're looking back into the universe's past as we look further away. So this is what I tell my students, that it makes telescopes like time machines, right? So by looking further away, we're looking back in time, all right, to the universe, into the universe's past, all right? The most distant galaxies in this image that we can see, at least at present, maybe if we look harder in the future, we'll be able to see more distant ones, emitted their light when the universe was less than 500 million years old, okay? So the age of the universe is very large. It's a lot older than any of us in this room. Does anybody know what the age of the universe is? 14 billion years old, okay? So it's very old, a little less than 14 billion, it's about 13 3/4. So again, the most distant galaxies emitted their light when the universe, in this image, emitted their light when the universe was 500 million years old, which is a lot less than 13 3/4 billion, right? So in human terms, the most distant stuff we can see is basically a preschool picture of the universe when it was just, maybe 3 years old or something. So again, the most distant things we can see are showing us what the universe was like when it was, a few years old in human terms. So a preschool picture of the universe. Any questions so far? That was probably the hardest thing I'll say, was all that stuff there. Yeah, okay. Yeah. Correct. Yep. Mm-hmm. Yeah, that's kind of crazy. It could have been dead for a long time. And in fact, with all certainty, there are, whenever you look at, when you go outside and look at the stars, almost everything you see is in our galaxy, so it's not really that far away. But if you look in this image, you're seeing things that are really far away. And so, yeah, many of those stars in those galaxies will have died in the meantime. And die for a star means lots of different things, but yeah. Is there an average lifespan of a star? That's a really good question. So stars, the life of a star depends on how big it is, how much stuff is in it. So for the sun, which is kind of an average star, the sun lives about 10 billion years in all. Okay, but much more massive stars have much shorter lifetimes, and much smaller stars have much longer lifetimes. Yeah. So yeah, it all depends on how big the star is. Yeah. Yeah.
If I got the terminology right, you said that the speed of the universe is a light year?
The speed limit of the universe is the speed of light.
The speed of light.
Yeah.
Is that, therefore we cannot measure it or understand it?
It's certainly possible. I mean, there's nothing that we know of that exceeds that speed limit. And as far as we know, that speed limit is built into not just things that we observe, but also into the laws of nature as we know them. But it's entirely possible. I mean, so I'm going to talk a little bit about what we don't know, right? And
maybe my question was, have there been any discoveries that might suggest there is some understand?
Well,
what you're saying is that speed is built into the laws of nature.
Right.
So that gives a lot of validity to it.
Right. Yeah. Not that we know of. There are a lot of things we don't know, though, that I'll mention in just a minute. Not related to that, but, who knows? Yeah. There's the known knowns and the unknown knowns and the unknown unknowns, and yeah, there's... all right. So anyway, getting back to this image. So the nearest galaxies are quite close to us. The most distant ones are very far. The nearest galaxies are telling us what the universe is like now. The most distant ones are telling us the universe as it was a long time ago. And then there's everything in between, right? So in this one image, we're seeing basically a series of snapshots of the universe's life. So you can imagine going to your dad or your mom's house, or maybe you have children and have done this yourself, where you put a series of images of your kids at different ages, right? And so you got the preschool picture, their first baseball game, and then when they become the awkward teenager, and then prom picture, and when they go up, you get the idea, right? So that's kind of what we're seeing here in terms of the universe, all right? But though this sampling here is really big, right? We're seeing tens of thousands of galaxies, but this is just a tiny little pinprick through the sky, right? So it just stared at one little tiny piece of the sky. The Hubble Space Telescope did. The entire observable universe, the part that we can see, is hundreds of billions of galaxies, right? So this is just tens of thousands. The observable universe is hundreds of billions of galaxies. The observable universe is just a small part of the entire universe, okay? And the entire universe, we don't even know the size of it. It's a lot bigger than the observable universe, and in principle, it could be infinite in size. But scientists are always uncomfortable with infinities because we can't quantify them really. Infinity doesn't work very well in mathematical equations, but who knows? So my short message here is encapsulated in this comic here. Can everybody see this to read it? So I'll read it out loud just in case. So there's two characters there. One says, "How are you?" And the other one says, "Trapped on the surface of a sphere." And then there's a pause. And then the first one says, "That astronomy class has made you suck at small talk." And the other one says, "The universe is too big for small talk." In my astronomy class that I just started on Wednesday, we're talking about scales in the universe. And so we spent actually a lot of time trying to give students a sense of, what does it mean that the universe is so big? And so we talk about the relative scales of the sun and the earth, and it's really fun to kind of go through those things and see people say like, oh, okay, I start to get how big things are, right? And what those scales mean in terms of things that I can understand. But anyway, part of what's astonishing to me about this image is both the wonder of what we do know and the tremendous amount that we don't. So it's both sides of this, what we know and what we don't. What we do know is that in every one of these galaxies, there are millions or billions of stars and planets, and that some of these planets might even have life on them. That's been one of the amazing discoveries in just the last 10 or 20 years of astronomy, is that in our galaxy, there's not just planets in our solar system, there's planets everywhere. And it's likely that some of those planets host life, or at least have the capacity to host life. We've learned a lot in the past century about how galaxies, stars, and planets function, how they change over time, and how they connect to life on Earth. But what we don't know is still an enormous list, right? So it's, thinking about what we do know, it's easy to, have some hubris, I think, but there's an incredible amount that we don't know. Is there other life in the universe? That's still a question we haven't answered. Is there other intelligent life in the universe? We don't know that. What is most of the universe made of? We don't even know that. So it turns out that most of the stuff in this picture you can't see, right? At least within our current theories, we think that there's something out there called dark matter, and then something even bigger called dark energy. We have no idea what these things are. We're looking really hard, but we don't know. And it turns out most of the stuff in the universe is invisible to us at present, and we don't know what it is. So what you see is just kind of the tip of the iceberg. Is our universe special because it is finely tuned for life to exist? So I read an interesting book when I was on sabbatical a couple years ago. a couple scientists who were talking about how the universe, the parameters of the universe and the laws of the universe are really unique in that they are such that life can exist. And if you change them just a little bit, in any direction, then we wouldn't be here, right? So what does that mean? What is the origin of the universe? What is its fate, right? So these are still questions that we don't have answers to. I mean, we have some ideas. We have something called the Big Bang Theory, but that only takes us back to the point at which the Big Bang began, and beyond that, we don't know. So again, kind of getting back to what attracts me to science, but I think, I would imagine that this is true for a lot of scientists, is that on one hand, we have discovery and understanding, right? So it's trying to figure out what's going on. And on the other hand, the mystery of the unknown. And I think these two things really have to live in tension for science to be a productive and interesting endeavor. So I love this quote that I read a few years ago by, this is Stan Woosley, who's a professor at the University of California. And he was talking about something called a supernova, which happens when stars die. And he says, for now, the supernova, and he was talking about some particular discovery. And he says, for now, the supernova offers astronomers their greatest thrill, something they do not understand, right? So, for scientists to find something and not understand it, like that's where you can make progress and have a good time. So again, science is really about the wonder of both the known and the unknown, and pursuing the beauty of the universe. This is another comic that I like to show my students. I'll read it to you again in case you can't see these small words. So again, two people. Well, this one involves three. The first two, one says, the problem with scientists is that you take the wonder and beauty out of everything by trying to analyze it. And then off screen it says, dude. And then here that person comes running, and she says, my plasmoidal slime molds have heightened pigment production. Check out that yellow color. That actually makes them zinc resistant. Amazing, huh? And then one of the first ones says, it looks like dog barf. And then the other one says, ha, yeah, F. septica is nicknamed dog vomit slime mold. Cool, huh? Check out my slides. And then the first one says, okay, never mind. What's wrong with scientists is that you do see wonder and beauty in everything. Oh God, it's moving. And then the other one says, it wants to hug you, so cute. I don't know if that actually exists, but but it might. So again, this idea that science really is about pursuing wonder and beauty in the universe. And before I talk a little bit about faith and how faith does that too, I just want to mention that science approaches knowledge in kind of a unique way. So I think it's easy to think of science as, particularly in the way I grew up learning science, which wasn't all that long ago, I think, although I'm getting older. Science is not a body of facts or just a set of weird terminology. So I think, in some sense, this comic kind of points that out a little bit, right? Is that it's not just about the funny names and the knowledge of these facts, right? But the way science really works is it's a process of testing models. So I like to think of scientists as sort of playing with tinker toys, right? Or Legos, and that it's really about building models of how the universe works, right? So we observe things, and we try to figure out what that means, but again, you have to remember that it's only a model of how the universe works, and models are never perfect, right? And really, the way science progresses is by breaking our models, right? So it's like, I don't know, my kids love to build Legos, and it's always, when one of their siblings breaks something with the Legos, right, then it, sometimes it's a disaster, right? That, oh no, and I always have to remind them, okay, Legos are meant to be built again and again and again and rebuilt and made into new things, and that's the fun of Legos, right? So scientific models are not these, perfect things that we just gaze at as if they're going to exist in perpetuity. They're meant to be broken and reformed and added to and always changing. Just as an example, how many of you here have ever experienced gravity? Raise your hand if you've experienced gravity. Okay, everyone's hand should be up. Can I? All right. So you've experienced gravity. Does anybody know who the guy who first quantified the law of universal gravitation is? Newton, that's right. So you all have heard this way back in science class when you took it, or maybe it wasn't that long ago for you. So Isaac Newton back in the 17th century came up with this law of universal gravitation. It worked great. It works great for us in our experience, right? But there are times when it stops working, okay, when it's not enough. And early in the 20th century, we learned that this law that Newton came up with wasn't quite good enough, okay? So we had to make some changes. That didn't mean we threw out, what he did. It just meant that, there are some really important, significant things about this that we have to change. So again, for a scientist, that's great. It means we've opened the door to discovery, all right? And I think it's also useful to say that science doesn't know anything with absolute certainty, right? So again, science is not a body of facts. It's a body of things that we observe and models that we create, right? And they're human constructs, right? So we have ideas about the universe. So again, scientists don't like to talk in certainties. We like to talk in probabilities. So if I take out my keys, right, and I drop them, what's going to happen? Gravity's going to pull them down? Are you sure? With what sort of probability could you say that's going to happen? 100%. Okay, well let's test our hypothesis, right? Phew. Okay. Yeah, that was relief. All right. I know you guys were on the edge of your seats, right? So when I drop my keys, right, they fall to the ground. But again, scientists can only say that with a certain probability, right? It may be 100%, but in reality, it's not 100%. It's really, really close to 100%. That means that every other time we've done that it's fallen to the ground. But that's how we make progress, is that someday maybe something different will happen. And some things, again, that was a very sort of silly example, but there are plenty of examples where scientists make experiments and they think they know what's going to happen, but then something else happens, right? So again, scientists like to talk in probabilities, not in certainties. All right, so let me talk a little bit about faith now, too. So again, thinking about how we experience wonder, a sense of wonder in science and faith. So again, I think just as in science, it's a tension between the known and the unknown, right? So in the life of faith, it's the same. And I know that Sandy did a really great job, even though I wasn't here. He forwarded me his what he talked about, and he did a great job talking about how the writers of the Bible talked about what they experience in the universe, particularly talking about the stars, the star in the east, right? That the wise ones looked for. So I'm not a clergyman here, but I do have, we all have our faith journeys. And I think in our faith journeys, we do have to balance the known and the unknown, what is knowable and what is unknowable. And that's a core part of the life of faith, right? And I think science and faith, mirror each other in that sense. So, of course, the known, right, is one way of describing the known. I'm sure there are other framings. Is our understanding of God as God reveals God's self in the world and in Scripture, right? And I love this quote from Galileo. So again, Galileo was a scientist, but he was also a person of faith. And there's lots of complex goings on. People like to talk about the conflict between Galileo's science and Galileo's faith. And I think historians of science and faith who dig into this realize that that's a bit of a that's not really a helpful framing of Galileo's story. and that it's a lot more complicated than that. And in fact, Galileo, I don't know that Galileo really had any trouble connecting his science and faith. So he talks about, he says this: we conclude that God is known first through nature, and then again, more particularly, by doctrine. By nature in his works, and by doctrine in his revealed word. All right. So there it's talking about how, in faith, we know God through Scripture and through nature. So even the Apostle Paul talks about how, in the beginning of Romans, talks about how we know, everyone has access to God just by living in the world, right? So I would maybe put that in the known category, but again, this is just my framing. And I might say that the unknown is the transcendent mystery of God, right? So, and kind of that word transcendence has almost the unknown built into it, right? So recently, I picked up a text. Maybe in the last year, I picked up a text from an early Christian writer whose name we don't know, but people call him or her Pseudo-Dionysius. That's kind of a weird, Pseudo-Dionysius. So this person actually wrote a really influential and important work on Christian mysticism, and this is called the Mystical Theology, and he wrote this around AD 500. And so here's just a short quote from that. I pray we could come to this darkness so far above light. So if only we lacked sight and knowledge so as to see, so as to know, unseeing and unknowing, that which lies beyond all vision and knowledge. So I'll repeat that. I pray we could come to this darkness so far above light. If only we lacked sight and knowledge so as to see, so as to know, unseeing and unknowing, that which lies beyond all vision and knowledge. So again, speaking of this inward journey of contemplation where we experience God in a way that goes beyond our reason, goes beyond our knowledge, goes beyond our experience of the world. And that tradition has continued up into the 20th century. So more recently, a 20th century monk, Thomas Merton, which many of you probably have heard of, speak of this approach to God in his book, New Seeds of Contemplation. So he says, true contemplation is the work of a love that transcends all satisfaction and all experience to rest in the night of pure and naked faith. This faith brings us so close to God that it may be said to touch and grasp him as he is, though in darkness. So again, it's this idea of an experience of God that is, in some sense, going beyond what we know, going beyond what we experience in the everyday world. And it is in this sense, God as unknowable, but God is still as someone that we can experience. Again, connecting these two points of science and faith and things that we know, things that we unknow or don't know, I think are both crucial to the life of a scientist and to the life of a person of faith. I want to end just by talking a little bit about how the relationship of science and faith helps us, right? So again, I kind of alluded to this briefly in that these two things, science and faith, are sometimes put in at odds with one another. And unfortunately, in our current political climate, that happens as well, because I think science is sometimes seen as the enemy of certain ideas on the right or the left. And I think science, so it's sometimes feared as something in opposition to faith and sometimes distrusted as a result. And I think what can help us overcome those is an understanding of what science can tell us and what it can't, right? So understanding, again, the limitations of the known in science and also a full understanding of what is unknown and what we can't know, using science. And that's key to using it appropriately. And I think there are pressing issues that, as Christians we're called to address, issues of Christian justice, for instance, that science can help us make informed decisions about. So another thing that I talk about with my students on the first day of class is that science is useful for us, right? So I ask them to think about 3 ways in which they use science to make decisions in their everyday lives. And I think we all do this, whether we're people of faith or not. But I think as people of faith, we're called to unique things, and I think science can actually help us with that, rather than working against us. And an important example that's been on my mind a lot lately is climate change. And I think, again, this is one of these really politically fraught issues, which is unfortunate, but it's one that science can sort of uniquely speak to. So the scientific models for climate change are things that are talked a lot about, right? And often talked around rather than talked about. And so I think, this idea that I was talking about earlier, right, that scientific models are our best guesses for how things work, but they're not perfect, right? So there are things that we're always trying to make better. But that doesn't mean they're useless, right? So they are useful for making predictions. But again, we never make predictions. Scientists never make predictions with absolute certainty, right? We always assign some sort of probability to the predictions we make. So again, in this context, right, the idea behind scientific models is that we do our best. We make our best guesses. And we make statements about what outcomes are likely, and then we encourage people to make decisions based on those probabilities. Are any of you in insurance? Well, even if you don't work in insurance, you've bought insurance, right? For your home, or for your car, or for your health. We do this all the time, right? So we're always making decisions based on, in essence, risk management, right? We're kind of hedging our bets because we know at some point something's going to happen, right? And so I think, when we're thinking about scientific models and how they're useful for making decisions in the world, that's not a bad way to think about it either. And so again, coming back to this particular example of climate change, which is, an issue that, even if politically divisive, is one that bears thinking about and bears, spending some time thinking about what the scientific models really are trying to tell us and how we might use that to make sort of informed, risk-based decisions on our behavior. And we do that based on what we do know, right? But also being humble and hopeful about what we don't know. All right, well, I will end there. And that gives us some time for questions, if you guys have any about anything I've talked about. Yeah?
Do you know if it's true that Hindu Vedas have anything to tell us about what we're talking about this morning? The origin of the universe?
Oh boy, they probably do. Yeah, so, I'm sorry, your name is? Q? Hugh, not Q, sorry. So Hugh is asking if the Hindu Vedas have anything to tell us about our understanding of the universe. Yeah, I mean, it's, I guess I would say, it's kind of taking off my science hat now and maybe putting on my faith hat. I would say that, I think truth is truth wherever we find it. And I'm sure that the Hindu tradition has, really important things to tell us as well. In terms of science, I don't know. That I'm not sure. But in terms of, the way we know God and know ourselves, I think certainly, yeah. But I'm not familiar with their particular tradition, yeah.
In a way, they sort of allude to a Big Bang theory.
Okay. Well, I don't know. So, but that brings up an interesting point. So one thing that I find really interesting, there was a fellow named Dennis Danielson who has studied sort of, he wrote a book once that basically picked out lots of different readings on cosmology, or our ideas about the universe, throughout human history. And he put them all together into a book called The Book of the Cosmos. And I haven't read through this, it's a big book. But it's kind of interesting to read bits and pieces here and there, and to see that lots of people have had ideas about how the universe works throughout human history. And what I find fascinating is that sometimes they get things right? At least in the sense of right in terms of how we understand the universe now, right? So, just because something is old and doesn't use modern methods of science doesn't mean it's not a useful way to think about the universe. So again, I think a good lesson in humility. Yeah. Good. Sure.
I'm from Middle East. Astronomy, science without books.
So you're thinking about going back to when we had oral traditions and
Yeah, during Christ's favor.
right.
They knew where they're going because of the star. Is there something to study about that?
Yeah. So I think the question is kind of about how was knowledge about the universe transmitted.
Yeah, there weren't any Galileo, there weren't anybody else. How did that become such fascinating science for early young people?
Yeah. No, I think that's an excellent question. So I think one thing to think about is that, so we live in a city, right, where we can't really see the stars very much. But, throughout most of human history, there haven't been electric lights, and the night sky has been just right there, And so I think historically, the reason for astronomy, is varied. So, I'm sure some of it had to do with trying to understand the seasons for planting, and some of it had to do with religious necessities, wanting, people. It seems like a lot of cultures used the movement of the stars to, govern religious ceremonies and things like that. Yeah, right. Astrology, where stars are connected to human activities, was a big thing throughout human history. I'm not an expert in sort of the history of astronomy, but I think it's the reason, the ways that knowledge was transmitted and the reasons it was pursued are sort of varied and interesting. Yeah. Right. Yeah. I'm sure there is plenty of oral transmission, and yeah, definitely. Yeah.
How far back does the use of the sextant go?
How far back does the use of the sextant go? Right. Yeah, yeah. So we sort of take for granted that wherever we are on the globe, if we have a cell phone, we know where we are, right? And that's a pretty recent phenomenon. So trying to find out where you are on the globe, right, has been a problem that has been really important, particularly when people started traversing the oceans. And one of the tools people used is called the sextant. So it's a way of basically measuring the height of stars above the horizon. And when people started using tools like that, I'm not sure. But I'm guessing that as soon as people started, traveling the oceans, they were. So I lived in Hawaii for a couple of years when I was a postdoctoral researcher at the University of Hawaii. And something I learned about there was the Polynesian Navigators, right? So Hawaii was settled by folks who came from somewhere else. And there's, a lot of people have studied, okay, how did these people traverse the oceans, and what tools did they use? They didn't have sextants, right? But it's likely that they used the stars in some way to navigate across these very large distances to find these very small islands. That's a good question. Sure.
I've gotten interested recently in this argument that consciousness is not something out there that's different from us and material.
Yeah. No, I think that's an excellent sort of a plug there. So I talked a lot about astronomy, but another really exciting science that a lot of my students are interested in is neuroscience. So the neuroscience program at Rhodes College is sort of growing by leaps and bounds because students are really interested in, and there's a lot of new tools to sort of scientifically try to understand what is consciousness. And I don't think we have any answers yet, and maybe we never will. I'm sure there will always be more questions about what's going on up here, right? But there's been a lot of amazing work on this in the last 10 or 20 years, yeah. A lot of which I don't know about, just because, I spend most of my time reading about astronomy or trying to get away from science when I'm at home, but but I think this is cool stuff, yeah. Sure.
As a scientist and a person of faith, how do you look at and approach the Bible?
Yeah, so no, I'm glad you asked that. So one really seminal moment for me in my faith journey was, so I went to was when I took an introduction to Bible class when I was in college. I went to a Christian college, so-called Christian college. I mean, it was a college where people, a lot of the students took their faith seriously, and where people were trying to, there was chapel and all this stuff. But I took this class, and I think before that, I had really not known how to connect science and faith, because I would read, say, the accounts in Genesis, and I would say, well, that doesn't really match with what science is telling me. And in this class, my professor said, oh, there are other ways to read the Bible besides theologically, right? So you can look at the Bible from a literary perspective or a historical perspective. And there, maybe that's sort of a simple thing to say, that there's more than one way to read the Bible, right? But for me, it was pretty revolutionary. And I could see that, oh wait, the Bible is not meant to be a science textbook. It was written for other reasons, and with other sources, and with other intents. So that kind of gave me the permission to take my science seriously and to take my faith seriously at the same time. Does that answer your question? Somewhat, yeah. I mean, the short answer is the Bible is not a science textbook, right? And that, and this is something that actually Sandy and I had talked about, but that I didn't get into my Sunday school, is how are the questions that science tries to answer and the questions that faith tries to answer the same or different? And I would say that they aren't always the same. So even though they both are trying to address wonder and beauty in the universe and the wonder and beauty of God, there are things that questions that science can answer that aren't necessarily, sometimes these things intersect, but they're not always the same. And yeah, maybe that gets a little bit more into your question. Yeah, Sandy.
The phrase that I like to use when I'm talking about questions, two different core truths, two different purposes for two different books.
That was a great way of saying it, yeah. And that, this idea that God, what Genesis tells me is that God made the world, that he cares about it, and that he cares about the details, he cares about us. And yeah, it's not necessarily, Genesis is not meant to tell us that the Big Bang happened, right? Yeah.
Gives us knowledge and insights.
Interesting. Oh, that's great. We all have a good rector here. He's filling in the gaps. I believe science will reveal the essence of God. Wow.
Sounds like a yes or no to me.
I'll stick with maybe. But leaning towards no, because I'm not sure that's the role of science. Yeah. All right, well, thank you all for paying attention. And